Welcome, everyone. Very excited to have you here. And before we get into the presentations, I just want to let you know that the Q&A session will begin after the final speaker. And during the talks, as questions arise, please put them in the chat. We will be taking note of the questions and we'll call on you during the Q&A session. And Ilka Cassidy from Hauz Systems has joined to help us out with the Q&A. So with that, I'm going to get to our first speaker, Amy Sims. Amy helped launch Plant Prefab, which is based in Southern California, and Plant's predecessor, Living Homes. She now guides Plant's design strategy, managing architect partnerships, design review services, and the development of new standard home designs. She got her start in sustainable design at Vermont's Yes Tomorrow Design Build School, getting familiar with energy efficient building techniques at a young age, and then went on to work as a framer and finished carpenter for several years before continuing with her architecture education. So welcome, Amy.
So my name's Amy Sims, and I'm the director of the, actually I was the director, I'm the vice president of design at Plant Prefab. And really the purpose of this presentation is to learn how Plant Prefab supports complex architectural designs and a range of performance standards utilizing a hybridized, panelized, and modular approach driven by advanced digital modeling, and to get a sneak preview of our new factory and learn about the integrated project delivery and hear how we help architects incorporate prefabrication with a combined expertise of more than 15 years of focused experience designing and building custom residential projects for prefab construction. In 2006, we opened an architectural design studio called Living Homes, and I was part of that founding team, as Barry said. We created our own sustainability measures for design and used the Lead for Homes guidelines as our system for quantification. That same year, our model home was built and became the first home in the country to receive platinum certification for Lead for Homes. The designs we focused on were solely sustainable residential projects for prefabricated construction. We worked with award-winning architects like Ray Cappy and Karen Timberlake. And over 10 years, we worked with 10 different factories and realized that what was greatly missing was a deep commitment to sustainability, quality, and customization. So in 2016, we created Plant Prefab as a solution. Everything we learned from those other factories was applied to design and patent a proprietary building system that's optimized for efficient and precise prefabrication of housing projects, thus getting the high quality sustainability and customization that was missing before. As a company, we've always been focused on slow, smart, steady growth. We just opened a second factory last summer, and we're in the process of building out our third factory now. We're very excited because this third factory will be our first automated facility, serving as a central production hub to drive even greater velocity at our existing and future Western US facilities. Each of these facilities builds on lessons learned and allows us to serve on projects of varying sizes and complexities. The production hub will be a 270,000 square foot facility capable of producing 1.1 million square feet a year, or roughly 2,350 modules. It's centrally located just south of Bakersfield on the I-15, providing immediate access to the West Coast principal shipping corridor. It's being outfitted with state-of-the-art equipment from cutting to framing, installation to finish, all driven by proprietary BIM data produced by our CAD engineers. This combination of precise building instructions and highly automated machinery will allow us to increase our production velocity 15 times over our other facilities and will provide a very high level of precision and quality assurance. Panels will be fabricated with insulation, installed by machinery, and thus increasing our quality potential. The facility will produce about 5,000 square feet of living space a day, with the ability to increase that velocity as needed with additional lines and staffing. All the components produced by this facility will be built to your specifications and finish level. So the varying degrees of performance that you want can easily be achieved. The image in this slide is of a full volumetric module, and this is part of a duplex that was designed by the Brown Studio. And the subsequent images that you see in all these slides are all projects that we've built at Plant Prefab. During the initial design review and pre-con process, we'll work with the project team to establish the most optimized prefabrication solution for your project based on the site and design constraints that you have. Basic components for the project may be modules or panels and/or some combination of both. And again, all the images in this slide are actually of one particular development project, and that's in Tahoe, and it's 30 homes built by or designed by the Brown Studio. And what's clever about them is they have 2 plan variations, and then each plan has a mirrored version. So ultimately they get 4 different housing types out of 2 plans. There are many different kinds of modules. Modules can be large, fully volumetric, or small core modules. Large volumetric modules may contain bathrooms and kitchens, but mostly they have a lot of space, bedrooms and living rooms. So we suggest when thinking about designing for modules that the modules be considered, bathrooms be considered as part of your overall design. Core modules, on the other hand, are specifically designed to contain the heaviest and most labor-intensive parts of the home, like kitchens and bathrooms, mechanical rooms. This allows all the finishes, fixtures, and equipment to be installed and tested before leaving the factory. Projects may have 1 or more core mod, and each will be dimensioned for optimal project scope. Core modules can be large or small, depending on your project needs. Core mods can also be connected to other modules or panels in order to complete your design. Wall panels can be shear walls or non-load bearing. Our exterior walls are typically built as a double wall. So this 2x6 exterior wall provides continuous, uninterrupted insulation, provides your structural shear. And on the inside of that, we have a 2x4 wall that acts as a chase for any plumbing, mechanical, electrical. This cavity can also be filled with insulation depending on your project specifications. Additionally, a 3rd layer of insulation can be applied to the exterior to be able to create a continuous thermal break. We build these panels to your exact specifications. So regardless of the project specs, all of the panels are built to Passive House standards for air sealing. Doors and windows, as you see in this image, may also be installed. Roof panels are typically structural and are generally 8 feet wide and between 36 and up to 40 feet long. These panels ship horizontally on a standard shipping trailer, which helps to reduce your overall shipping costs. Insulation may be included in these panels depending on the amount of finish work and MEP contained within those panels. Typically, the exterior roof materials are installed on site in order to meet the manufacturer's warranty and waterproofing requirements. This particular project was not Passive House, and therefore we do not see gaskets running along the perimeter of these panels. And I'll say one challenge with being a custom fabricator is that we don't always win the battle to push the team toward building a tighter building envelope. Plant has really industry-leading engineering capabilities optimized over the last 5 years to enable the efficient custom prefabrication of any housing typology designed by any architect with any level of finish. We call it the Plant Virtual Build process. Our team of CAD engineers virtually constructs your entire project before it enters production. This is a key differentiator for Plant as it bridges the gap between design and construction to drive efficiency and quality at every stage of the process. So in other words, we're literally building your whole entire project. We're running the MEP through, we're doing clash detection. You can see here, we're including the STS straps that connect mod to mod. And this greatly reduces the amount of time and rework that we have once we're building the mods in the factory. The data produced in this plant virtual build process also includes a detailed construction drawings and cut list for the factory, component level identification for project tracking, component weights and shipping, and detailed instructions for component field assembly and more. Here's a really quick simulation of a 4-module, 35-panel home that is part of that development I showed you earlier. Sorry, I'm having a little bit of technical difficulties. We'll do it again. So you can see the sequencing of the installation. That's part of all of the instruction assembly that we're sending up to the site GC as well. This home took 15 hours to assemble on site. Our flexible system allows our capability of building all different project types, from single family, ADU, multi-unit, single family, as well as multifamily. So very quickly, I wanted to show you this case study that consists of 31 500 square foot A-frame ski cabins. Each of these is taking approximately 8 to 10 weeks. And initially, the developer came to us requesting that these units be built as 2 modules. But as you can see in this diagram here, if we had built this as 2 modules, it would have been very challenging to align all these roof panels. It would have cost a lot more to ship all the way from Southern California to Winter Park, Colorado. So instead, we suggested making this a hybrid system. So if you see the floor plan on the left, there are 2 blue areas that show the very small core modules, which is the kitchen and the bathroom. The rest of the project, if you think about an A-frame, there's a lot of space. There's a loft, and then there's the double height space in front of that kitchen bath area. So the rest of that is built as panels. So overall, we had 19 different panels and 2 modules. We even sent the ridge beam as part of our installation kit that went up to the site. And here it is on installation day. The beauty of this design also allowed us to use a smaller crane, because part of the site constraints was the desire to leave these trees. So by having a smaller crane, we're able to get in and maneuver a lot more quickly than we could with a larger crane. Thank you.
Thanks, Amy. That was great. Lots of information there. Our next speaker is going to be Andrew Dye, who is the Chief Operating Officer at Unity Homes in Walpole, New Hampshire. He's been working for the last 7 years there on lowering the cost of high-performance homes. His career in construction has included general contracting, project management, consulting, teaching, and writing. Welcome, Andrew.
Thank you, Mary. I'm going to share my screen. And hopefully you're all seeing that now. Maybe you can hear me. I'm going to talk quickly because 12 minutes isn't a lot of time to describe what our company does and how we do it. I'm going to start with just a brief overview of Unity Homes and our sister company, Bensonwood. I'm going to touch on our design system, which is a key part of our process. And then I'm actually going to spend most of the time talking about airtightness and how we achieve it, because that's sort of the most passive housey thing that Unity does, is consistently achieve passive house levels of airtightness using our offsite and onsite methods. Unity was founded in 2012 as an offshoot of Bensonwood Homes. At the time, Bensonwood was about a 40-year-old company that was known for building high-end timber frame homes and panelized homes. But they were working at a very high end and still work at a very high end of the market. And there'd always been this idea within Bensonwood, wouldn't it be nice to make this high quality home available to a broader market, to more people? We tried to do it in various ways within Bensonwood, and ultimately ended up spinning off a separate company to do that with a separate mission of making these homes more available. So that's what we've been working on at Unity for the last 10 years, really building on the knowledge and the heritage of Bensonwood. The two companies are still kind of attached at the hip. Of the 135 people that comprise Unity and Bensonwood. Most of those are actually Bensonwood. Unity has about 15 employees, the rest are Bensonwood. Bensonwood is doing all of the fabrication and the installation for Unity. So in one sense, Unity is Bensonwood's biggest customer. Unity has been building about 20 homes a year. It looks like in 2022, we're going to build closer to 30 homes. And our territory is primarily New England or the Northeast. There's no reason in principle we can't ship farther afield. And we recently assembled a shell of a home in Buffalo, Wyoming. But the farther away we go from our New Hampshire base, the more expensive it is to truck and travel. And that takes a bite out of the budget. And environmentally, the carbon footprint is larger as well. Like all of you, we're trying to build homes that are healthy and comfortable. Those seem to be sort of the two main things that our clients are interested in. Energy efficiency ranks up there as well, with low operating costs, low utility bills, living more lightly on the planet. We're trying to build sustainably, and increasingly resilience is on people's minds, and we build that into every house. Predictability is also a key part of our value proposition, as with these other offsite companies represented here this evening. By building in the controlled conditions of a factory, we have much more control over the cost of the project, over the schedule of the project, over the quality, and over the performance of the finished home. We have 3 facilities. This is a view of our 110,000 square foot panel production facility in Keene, New Hampshire. That's again for both Bensonwood and Unity. The solar array on the roof creates about 2/3 of the power that the factory uses. We have 2 other facilities. One is a timber frame shop, about 30,000 square feet in Walpole, New Hampshire, and an adjacent millwork shop. So we're quite vertically integrated between the 2 companies. This is an inside shot of the wall line of the panel production facility that's inside the panel shop. There are actually 3 lines within the shop. This is the wall line. We also have a roof panel line. And then we've got a line that we call the open cavity line, which is where we build the floor panels and like porch roof panels that don't require insulation. So we build the panels here, we install the windows and doors, we bundle them up either vertically for wall panels or horizontally for roof panels and floor panels. We tarp them, we stage them out in the yard, then we ship them to the site, and we assemble them quickly on site. Typically it takes about a week to put up a typical Unity home to get it to the weather tight shell stage. This is a barn style home that we built in New Jersey a couple of years ago, and we typically were sending the crews to do the assembly to ensure the quality of the installed shell. I'm going to talk just a little bit about the design system. This is something we've been developing over the last decade and continue to refine it. One of the ways that we're lowering the cost of these high quality homes is to get rid of the architects. At least that's what we're trying to do. And I realize I'm speaking of a bunch of architects. We actually have architects on staff, but the idea is to develop a design system that embodies that intelligence and experience of the architects without having to custom design each house. And so we have these 5 design platforms, we call them, or design starting points. They've got funny names. You can read more about them and see them on the Unity's website. And each of these platforms has associated with it different component parts that are pre-designed and pre-engineered and pre-priced, and they fit together in specific ways. You can't just put them together any old way, but there are specific ways in which we configure the design using the platforms and the parts and pieces so that they fit a particular site, a particular design program, and a particular budget. These images show sort of the 3D visualization conceptually of the platforms and a kit of parts. This 2-dimensional representation is something that we've been developing more recently, and our sales team is finding that it's just a great tool. We have basically options, floor plan options for different locations within the house. So for a kitchen area in a barn, we might have a half a dozen different kitchen designs that we've developed and vetted, both for the function and the mechanical layout and everything. There will be multiple layouts for primary bedroom suites or for connectors, different locations for screen porches. And this is a nice visual way to get people to understand how the system works. We've been having a lot of success with this. Passive House, Unity doesn't build passive houses, so I'm pleased to be able to speak to you about what we do. A little intimidated also because we're generally not hitting all of the, checking all the boxes for Passive House. But Bensonwood built its first Passive House in 2010. It was this house in Norwich, Vermont, which was a collaboration with Zero Energy Design out of Boston. And one of the interesting learnings that came out of that project, this was before Unity was founded, was that we didn't have to change a lot in order to meet the Passive House level of air tightness in terms of what we were already doing. We have a long history of building timber frame homes and enclosing them with SIPS panels. And then in the early 2000s, we started making our own panels. So just making a few tweaks to the materials and methods, we were actually able to achieve the Passive House standard of air tightness without really significantly increasing the cost of the project. And we've translated that into what Unity does. The methods that we use seem to be particularly well suited to achieving these air tightness standards. Bensonwood has continued to build passive houses. It's not every project they do. And I think I noticed that actually Buck Moorhead is attending this webinar, and I think Bensonwood has built at least one passive house with him at a development down in the Catskills, and they're planning to build more. You don't need to really grasp this whole thing, but basically I did a quick review of the last 20 or so Unity projects in terms of the blower door test results that we've been tracking. There are a few Bensonwood projects, because I was kind of curious. We tell people that consistently we reach that passive house level of air tightness, which is 0.6 air changes per hour at 50 pascals of depressurization with a blower door test. And so I just took the last 20 or so projects and averaged them out, and we're at 0.62 as an average blower door test result for CFM 50. So I can feel confident now when I say that to people, and that I actually know what I'm talking about. So how do we do that? How do we achieve this air tightness consistently? It's through the planning, it's through the prefabrication that we do of these large components, and then assembling them on site with highly evolved methods. So I'm going to talk about how we do that and show some pictures. It starts with a 3D model. We're using CAD Work. We design in the 3D model, and then the 3D model gets elaborated. So all the parts and pieces get put into the model through these various elaboration routines. And then the machine files that tell the CNC machines in the shop what to do are exported from that 3D model. So here's a photo of one of the multi-function bridges in the Weinmann wall panel line that we're using in our panel shop. This is a multi-function bridge that does fastening and routing and vacuuming. So it's installing the inner skin, the inside skin on the wall panel, which is 7/16 OSB. We're using dense pack cellulose as the insulation, and typically we're using I-joists or I-studs, 9.5-inch I-studs in the walls, 11 7/8 or 14-inch deep I-rafters for the roof. So this would be our roof panel line. That Isocell machine is injecting a specific amount of cellulose into those cavities. It's all computer controlled to achieve the density that we're after, which is 3.5 to 4 pounds per cubic foot, a little higher density maybe than you're used to with dense pack cellulose, but we are transporting these panels, and we found that that's optimal to prevent any settling. The panels that we're building are designed to be vapor open, so they dry to the inside and the outside. We're typically using zip sheeting on the outside. So here, Gray is rolling the zip tape on in the shop. The other wall panel that we do use sometimes is 2x8 studs with 1 9/16 wood fiberboard insulation continuously on the exterior. So here Toby is installing some tape on the joints between the wood fiberboard insulation. We pre-install all the windows and doors in the shop, so that gives us good control over the air sealing and also the flashing around those critical areas, those openings in the wall panels. Here's a picture of a door that's been pre-installed in the shop. And then when we get to the site, we're applying these panels onto the foundation, or in this case, it's a slab. We do actually a lot of, probably half the houses we built are on slabs, which is kind of unusual for New England, but it's one of the ways that we found that helps us with the affordability, because the concrete can be used as a finished floor. You'll notice that the vapor barrier that's under the slab has been left long so that it can be wrapped up and taped to the wall panels to keep that air barrier continuous all the way around the house. Here's a second floor wall panel being installed on a Varm style house. You can see the gaskets there where the two wall panels are going to meet in an outside corner. You can see the taping that we do on that inner skin of the wall panel, all the wall panels. And then what look like studs there, those vertical 2x are actually, that's the service layer, the service cavity is created by 2.5-inch deep. It's 2x3s on edge basically, and that's a space for running wires and maybe pipes, because we don't want to be compromising the air barrier or the insulation of the structure when the MEP gets installed. And I think Amy referenced that they're using a similar layer to run those mechanicals. This may be a little hard to interpret, but we're looking on the right of the slide there at a gasket that's been installed on the top of a first floor wall panel prior to the installation of the second floor wall panel, and you get a good view of that 2x3 service layer as well. Many of our homes have vaulted roofs that are created by insulated roof panels. This is a trad style home that has some timbers in it. You can see the taping of the seams there on that inner skin. And those two penetrations were preformed in the shop. We put all the mechanicals into the 3D model so we know where the penetrations need to be for things like, in this case, it's the intake and exhaust for the ventilation system, the HRV. But we do that as well for dryer vents and for outlets and exterior lights, plumbing vents. So here's a dryer vent. And the idea is that if we provide these preformed penetrations, then the subcontractors just need to use those to go through the wall or through the roof. And then with some spray foam, we're able to maintain the integrity of the air barrier of the house. Here's a shot of a sleeve that's been installed in a roof panel above a bathroom, and the plumber is going to run the plumbing vent through that and spray foam that, preventing the bathroom plumbing. Not all of our houses have vaulted roofs. Some of them we frame with trusses, standard dimension lumber trusses at 24 inches on center, and that's another way that we're trying to make these homes more affordable. For houses with truss roofs, we're installing a Mitel membrane on the underside of the trusses. We're taping the seams of that membrane, and then we're installing 2x on the flat to allow for the installation of the interior partitions. You can see here how that the service layer is used for wiring. We actually notch the back sides of those 2x3s to facilitate wiring. And for all the studs that we use for the interior partition walls that we prefabricate in the shop, we're also pre-drilling holes so that there's really minimal to no drilling that's required by the electrician to run the wires. Here's a shot of a completed shell. This is a trad style home that we completed recently. And that's the way our crew would leave it so that the exterior finishing and the interior MEP can begin when our crew is done. Just want to leave you with a couple of thoughts about kind of the challenges that we're facing these days. Cost is always a challenge because these are very high quality homes with triple glazed, tilt turn windows and foot thick walls. And but we haven't been willing to compromise on the quality, and so it is still a premium product. Before the pandemic, I was telling everybody wants to know how much per square foot, right? And there's so many factors that affect the cost, but I might have said $250 to $350 a square foot for a completed home, exclusive of the site work prior to the pandemic. But as we all know, things have been going kind of nuts for the last couple of years. And these days, I'd probably put the typical cost of a Unity home in the $350 to $400 a square foot range. Probably sounds expensive to some of you. It probably sounds pretty reasonable to others, but that's kind of where we're at right now. I'm putting carbon in there because I think we all know that the operational carbon, the carbon emissions from operating these high performance homes is actually pretty good. And that's one of the reasons we've been building them. But increasingly, there's a focus on the embodied carbon. So the carbon that's required to harvest and transport and put together the raw materials for these houses. And that's something we're looking at more closely to really try and move the needle on that in the next few years. And I put CAD CAM there as well. That's sort of just a shorthand for the software that we've been developing for the last few years and that we're starting to use in the sales process that is integrating the design process and the manufacturing process in a way that they haven't typically been integrated for us. And eventually this software is going to be taking information from manufacturers and suppliers and subcontractors and others to create better integration in what historically has been a disintegrated or fragmented design and construction industry. I think that's all I have.
Thanks, Andrew. Next up is Kyle. Kyle Moen has worked for BC Passive House for the past 7 years as the sales and planning manager. Kyle's work mainly focuses on project development and execution, labor and materials budgeting and procurement, and R&D through the application of informed building science. He's overseen the construction of several registered passive houses and step code low energy homes using the company's high performance panel systems. Welcome, Kyle.
Thanks, Mary. I'm just gonna share my screen. Thanks for the introduction. As Mary mentioned, I've been at BC Passive House since 2013. So BC Passive House is located in Pemberton, BC, which is 2 hours north of Vancouver in British Columbia. I would say for the most part, our work has been in the region of BC. We've gone as far north as the Yukon, worked a lot on Vancouver Island and in the interior of British Columbia as well, and some projects down in Washington. BC Passive House is a fully integrated shop, so working with clients at the start through shop drawings, framing, and then doing our own installations on site. And then we've recently done an expansion, so pretty small compared to some of the previous presenters, but we're now at 40,000 square feet. And our main additions recently have been a CNC machine, so that would be a Hundiger K2i, and a framing line from Sukup, which has speeded up our panelization process quite significantly. Just a quick look at some of the systems we build. The majority have been sort of in the light frame range, and mostly custom. I guess our local environment with seismic and geography, sloping sites and that kind of thing has lended a bit more to building per project. And the panel system we've developed gives us a lot of flexibility in that regard. We've also built larger stuff, including MERB. So one of those is a 24-unit apartment building. Another is quite a large health and wellness center for First Nations in British Columbia. So we have our light frame system, and then we also integrate with a lot of mass timber as well. So we're wood specialists, really. So some of the bigger stuff we'll be using products like CLT, sort of as hybrid systems with the panelization, and then mass timber for aesthetics as well. So one of those photos is a demonstration project where we use 5 different types of mass timber as basically a way to showcase the technology and what we could do with our panelized system, and also with the products that are available on the market. There's been a bit of a discussion about the steps from getting from sort of a concept through to a 3D drawing. That seems to be the hardest with us, especially as custom builders. So for us, we always recommend that people approach us early in their construction stage, ideally after they have a lot. We can start commenting on architecture and engineering that works well with prefab. We've also recently brought in an engineering team into our company, and some design work as well, so that we can kind of smooth that transition through from this kind of concept through to getting a 3D model, which we also use CAD Work, which is a repeating theme here. Getting from CAD Work then to the shop floor. So after the 3D model is sort of worked on and fully developed and signed off by engineer and architect, we can produce these highly detailed shop drawings where we're drawing components right down to the last stud and screw, and also drawing within the 3D model the key interfaces. So that would be concrete and steel, not components we're going to produce, but most importantly, as we're building the superstructure, these components can be put together on site, and then we can come in and either wrap our shell or our hybrid structure to create the envelope system, high performance envelope system. What is now kind of the heart of our prefab process is a Hundiger K2i. So this allows us to this allows us to really start from the beginning in the prefab process, yeah, so the Hundiger can cut a volume, so in a range of 16 inches wide up to 49 inches long, or sorry, 60 feet long and 49 inches wide. So this can really cut just about anything in terms of what we prefabricate, and then we can also bring in a range of mass timber systems as well. And Hundiger communicates with a software program called Cambium, and Cambium allows us to interface between CAD Work and the Hundiger, and this has some unique advantages. So Cambium can visualize and simulate cuts. So This ensures the machine's capability and efficiency. It also allows us to sequence the cutting order to integrate nearly seamlessly with the framing process. It stamps each piece that we cut with a unique ID so that we can integrate that into the framing process. And it prepares critical pieces like plates and notching to inform our framing line. So if you look closely on the detail there, we can go as far as even making cuts that aren't typical for sort of a regular framing process and speed up the framing line, which for us is a big deal. We still do a lot of our framing manually. So the extra, I guess, benefit that the Hundigger and through Cambium offers is a very, very useful thing that's sped us up quite a bit. Some more modern equipment that we've added. And I've actually seen the Isocell machine a couple of times already. So this is a high-powered installation machine. We have our Sukup framing line, which includes a butterfly table. So this way we can move panels through the framing line quickly and then flip them after we've finished one side of sheathing. And in the future, we've kind of set up our plant so that we can adapt to more of a robotic system. That'll be the next big step for us, as we're mostly in terms of framing on manual labor. And with the framing line and with Hundigger / Cambium, we'll start to incorporate more, even more equipment like nailing bridges and robotic framers to speed up that process. Hundigger, or sorry, the CAD Work system also offers us this unique advantage of programming our loading as well, so we can preload trailers virtually, and then that information can get passed down to the shop floor so that the team can assemble trailers for sending them to site very quickly. And then I think the last step, which is for us, and as I see for a long time, is going to be done with the human touch, is installation. So we look after our own installations. We've done this in some pretty challenging environments. One of those is on the top of a mountain set up by helicopter. And then other ones, as long as we can get a truck to site and we can understand the dynamics of the transport process, then we can load our trailers accordingly, and we can get cranes in and we can assemble homes very quickly. Just a couple more looks at some installation processes. Accuracy is key, and you can see when it comes to landing huge roof panels and that kind of thing that everything needs to be perfectly dialed. So that's for us as a custom builder, our focus is on accuracy, especially on these larger setups, and really as installations, kind of the client interface between what the client will see and what they get on site. When we start to when we complete a setup, then we want to integrate or incorporate the quality control. And so after a setup's complete, we'll go as far as adding membranes on the roof. We'll have WRB membrane on. In the plant, we'll pre-wrap windows. Really, I guess the last step from we're building an entire house within the plant, we're ensuring quality control because the product never actually sees the environment or any kind of climatic weather. So when we bring it to site, then we want to ensure that that quality is maintained and that the handoff is clean. And then the last point, we're a wood-focused builder, and I think, I mean, this is the passive house discussion, and one of the things that seems to be missing in passive house sometimes is this discussion around material use. So we try to, and we sort of developed our system around using wood as much as we possibly can. So that goes from the post and beam systems, where we're using glulam and mass timber as the key structural systems, and then bringing wood fiber insulation into our panels. So we're almost an exclusively wood builder. Yeah, so energy efficient homes and good material use is our company motto. So yeah, thank you.
Great. Thanks so much, Kyle. And next up is Jan Pratschke, who is CEO, co-owner, and head of design at Collective Carpentry in Invermere, British Columbia. He oversees the design process and the production of all 3D models, shop drawings, cut lists, and install drawings for the shop and install teams. He brings a timber framing and business background to his work and hails originally from Dublin, Ireland. Welcome, Jan.
Thank you, Mary. Thank you, everyone, for having me here. It's such an honor to be here with my other prefab compadres, and really great company for Collective Carpentry to be with you guys. We're a little bit of a smaller operation than some of the other guys out there. We are this is our sort of our goal. Aiming to be one of the leading manufacturers of pre-designed and custom super insulated wood-based structural panels and parts for thoughtful, principled, and environmentally sustainable residential, commercial, and institutional buildings. So really everything we've done from the beginning has been a quest to build high-performing homes. And from the outset, that's just me. You've already heard about me. From the outset, that was driven by Passive House principles. Some of the first projects that we did were passive houses, and everything we do is really driven by the principles of Passive House. That doesn't mean that we necessarily always achieve Passive House or the projects that we're working on are even intending to be certified as passive houses, but the principles, airtightness and climate appropriate amounts of insulation, attention to detail, those have always been our driving motivations. And I think it's probably about a third of the time that actually leads to a certified passive house. I like to think most of the time it leads to a really comfortable, high-performing home. And for the most part, I'd say our airtightness kind of averages around just a little bit less than 0.6. There have definitely been a few that have been over 0.6, but for the most part we're ranging around 0.4, 0.5 air changes. So we're primarily building single family residential, and we have in the past built a few institutional buildings, a church, a health center, a fire hall. And we do have some multifamily projects that are in the works, so we'll see if that comes along. But first and foremost, our experience has been driven by building custom single-family residential. So I think most of you know the different kind of types of prefab, panelized construction being one, and that's such as BC Passive House and Phoenix House and EcoCore and Unity Homes, Bensonwood. And then Amy showed you a little bit of hybrid construction with a nice combination of panelized and modular. And then of course there's modular. So CC has focused entirely on panelized construction. There are a few reasons why. One of them might be just the fact that we are located in a small rural environment. We're always often shipping fairly significant distances, and panelized construction just allows us to get a little bit more on a truck. It also allows us to leverage our very small shop in comparison to the others. We have 3,000 square feet of shop space. So Kyle mentioned his small 40,000 square feet, but we're dwarfing that quite a bit. So we're really proud of what we can achieve in our small little shop. But the idea of building modules was bandied about for about 15 minutes, and then that was that. So we build panels for pre-designed panel project with B Public Prefab, with whom we are a manufacturer. We will soon build panels for our own line of pre-designed homes, and we have built panels for pre-designed homes, a pre-designed home, from Artisans Group, and I know B Public has some pre-designed homes that they're offering as well. So our collective homes will be doing an announcement and launching in a few months. So we're really proud of all that work that's gone into that, and it's been a long time coming. And of course, we do panels primarily for custom prefab. So we have a building system that is defined really from experience building custom panels for different designers, different projects. We've built a ton of different types of wall systems, floor systems, and roof systems. And there are pros and cons, of course, with everything. But we've started to hone in how we like to build things, and we've started to define that as our system, or certainly that's how we articulate it to people. We have 3 different wall types. There's a 2-layered I-joist based base wall system that has structural inner layer and then airtight sheeting, and then an outer cavity that's framed with I-joists. And then we have wood fiberboard wall. So there's open framing with wood fiberboard outside instead of the I-joist framing cavity. And then there's sort of a wall panel that's sort of similar to how BC Passive House built some of their walls, and perhaps similar to Bensonwood and Unity Homes in that it's a single layered structural insulated framed panel. So a few different ways to do things. A lot of the time it's architect driven. It can be cost driven. These decisions can be based on there being a small building site, perhaps, and trying to optimize trucks for cost effective shipping and whatnot. So when we do an installation, we are usually thinking about it in terms of delivering a structurally intact building. So it will have building panels primarily, and then there will always be some sort of loose parts that will be part of the install, such as drop beams, posts, sometimes integration with steel and other components. So we just sort of call those the associated parts. But the goal is when we finish an installation that the building is complete. It is thermally complete. It's it's meeting all the architectural requirements, and it's structurally sound, and all connections are made. So that's the goal of our installations. There's a little quick snapshot of Collective Homes. So we'll be launching, like I said, this in the coming months. We're really excited about it. I won't dwell too much on the idea of shop expansions, because you saw some really nice imagery and video from Plant and from Andrew at Unity and from Kyle at BC Passive House. But we do as well have some goals of increasing the capacity that our facility can manage, and that will definitely include some machinery and semi-automated equipment at first, integrating with our software and our experience with that. And the goal down the line would be to develop the business, of course. And if that leads down to kind of more robots, then that's good, that's fine. But that's not necessarily the goal. The goal would just be to be increasing capacity, maintaining quality, keeping a safe working environment for the crew. So yeah, what is it you would say you do here? So my role as a co-owner, I used to wear many hats. I started off in the shop, building panels, doing the design work, building the panels, helping with install. I have since, as we've become busier and our team has grown, I've since started to hone in just on managing our growing design team. So my focus is primarily, or almost 100% now, working with the software that we use, which is CAD Work, just like everyone else, and working with architects and engineers and builders and clients to bring them through the whole design review process, basically the whole planning process. And I like to say, my primary goal is really trying to achieve the architecture, trying to satisfy engineers, and all the while trying to maintain thermal airtightness and weather barrier continuity, and all the while trying to take account for all those criteria and trying to chop up panels and fit them on a truck so we can bring them down the road and install them. So our planning process has 4 stages. We've got the initial contact, and planning, getting towards contract. Then where I come in, as I described, the design review process. And then we have production and installation. We often have, some tough questions with clients early on. What does it cost? That is variable, of course. What's the lead time? We can, we're typically able to deliver from early contact to doing an installation, somewhere between kind of 8 to 10 months. In some cases, when we're working with B Public Prefab, for example, we can shorten that timeline because of all the design legwork is mostly accomplished ahead of time. So we're able to shorten that timeline quite a bit. But typically for a custom prefab house, we're gonna, I'd say if I gave a safe guess, about 8 to 12 months would be a fairly good guess. Can you design my house? The answer would be no. We can. Hopefully you might find it interesting to work with one of our pre-designed homes, but as far as architectural design goes, we do not do, as of right now, we do not do any custom design, but we can recommend you to lots of our partnering architectural firms. Can you build my house? No, we used to be general contractors, but we're not anymore. We're focusing on prefab now. And how do I optimize my design for prefab? Really, it's about starting early at the beginning. We have lots of details that we can share. We have the collective building system that we've developed that can sort of give you a few design parameters, different sort of shippable component sizes and things like that that'll have an effect on cost and efficiency to build. And we have a design guide that is a summary of all these details and system parameters that we're working on. Basically, it's not quite ready to publish. So there would be, client priorities early on in the planning process. We have to help clients understand what products and services we can provide. So like I said, we can do that through our design guide, website, brochures, often just a lot of phone chats. And of course, in the last couple of years, a lot of phone and video chats. Early is the best time for us to be involved. It's definitely, I'm sure it's a tough thing for a designer, architect, builder, client to integrate prefab really early because you don't necessarily know the cost implications. But if we could come in early and have a role in the design, it can really have a positive effect on bringing the costs down and bringing just the efficiency of the process up. We can often manage to take a design that's fairly far down the road, but it can be a struggle. So it's much better to be in early. And yeah, like I said, 10 to 12, I think I said 8 to 12, but there you go, 10 to 12 months is fairly standard for us to be able to deliver, and it can be quicker. And the bottom is just a visual of, we fit in somewhere in the middle there. And there's obviously lots of work that a project consultants will be working on before we get involved, and lots afterwards as well. Designer priorities. So this would be the priorities, things that designers and architects and designers might want to think of when they're thinking about prefab. So material choices. This has been a wild one lately, of course, just due to fluctuations in supply and cost. So it's kind of changing daily, certainly weekly, and we're doing our best to make smart purchasing decisions and store material effectively to manage inventory and things like that. But it's been a really interesting and difficult and somewhat expensive time. The connection details, of course, we're going to talk about connection details. There are all sorts of considerations for connection details. Different types of panels have different ways that things can be connected. Open framing can be much simpler to connect things. And some of the walls that are single layered insulated and structural layers are quite a bit more difficult to connect. So we need to get creative with different hold downs, different methods of anchoring walls and connecting them to each other, all the while trying to manage the continuity of airtightness, thermal continuity, and trying to make sure that the panel that's delivered, it can be installed quickly, so that we can keep the water out, basically. There are always going to be logistical considerations that a designer is going to become involved with as well early on. Installation can be affected, or installation effectiveness or efficiency can be greatly influenced by window and door sizes, things like that. Those are going to sort of dictate panel sizes, panel shapes, how we break up panels, the number of panels, all sorts of things. Builder priorities would be, I think builders most often come to us looking for contract specific, things. How do they manage their prime contracts with our subcontracts and different, depending on the contract? How do they manage payment schedules, terms? how do they ensure that their site is going to be ready for our delivery, ready for large trucks and trailers, and ready for that that terrain to not be harmed, ready for a place for a crane to park, and telehandlers, forklifts, all that sort of stuff to work. So that's what builders are usually thinking about. They need to know, when does their scope end, and when do we start, or when do they stop, and when we start, and then when we finish our install, what are they going to have to work with? And we take quite a bit of we put a lot of work towards making sure that a contractor is left as ready as possible for their siding, for their window and door installations. So we detail the sills on rough openings so that windows and doors are ready to go in. And we find most of the time contractors are fairly surprised with how quickly they have to kind of get those things, how quickly they have to get their roofer lined up, because from foundation to needing a roof could be 2 weeks if everything works out the way it should and could. Design review, yeah, part of the design review process for me would be taking, for me and our design team would be taking architectural and structural drawings and doing 3D modeling and building the entire building in our 3D software, which is going to show all the parts down to different types of connections and hardware. And from that 3D model, we generate a few staged review processes. The review one would be more an architectural review that would be verifying window and door locations, wall heights, roof slopes, things like that. And upon the approval of that stage, the review one, we would progress to really adding all the parts to our model. And that's when it becomes a little bit more of an engineering review. There's perhaps going to be architectural revisions and changes, but when we get just before fabrication, we're really dialing in all the connections for engineers. And once that stage is finished, it's final fabrication prep, which is when we break up panels into parts and we group them into parts and prep the shop drawings and make material lists for ordering and for cutting, and that's when we get ready for fabrication. And we've got production. Production is exciting. That means we've gotten all of the planning out of the way, and it's amazing how dynamic it can be. You think you might have the next few months all set in stone, but I think, as everybody here knows, there are a ton of different things, different ways a project can get sidelined or sideswiped. And for us, our job is just to make sure that we're ready as soon as the building permit is issued, as soon as all financing is approved and all the shop drawings are approved, that we're ready to go. And as part of our fabrication, we photo document, and in some cases video document, the panel production, shear wall nailing patterns. Anything basically that can't be seen inside the panel is going to be documented and stored, and then sent to whatever consultant requires it. And we are really lucky to have our a couple of installation teams. We have an installation team, dedicated installation team in the US, and our Canadian shop crew does installations in Canada. So part of the installation team's requirements to be working with the builder, to verify the site readiness and make sure that there's room for cranes, for panel deliveries, and for scaffold, things like that. Make sure that the site's ready and safe. We will always check the site, whether it's a slab on grade or whether it's a wood frame foundation. We'll always check it for level and adjust as required. And we also do windows and doors and other install and quality control inspections and review as part of our install procedures. So in addition, like I said, we offer complete installation in Canada and the US, and we can be nationwide. We're typically, or mostly, on the West Coast, as you can see, or on the western side of the continent. Anyway, we do have a couple of installs on the East Coast. We will have panels fabricated by Simple Life Homes in Ontario. They'll build some panels for Public Prefab with some of our design coordination for a project in Massachusetts. So we're not afraid to travel. We like to travel. We love to be a part of the install procedure. Just provide such an amazing feedback loop to have been a part of the planning and the modeling and the shop drawings, and then get to see the result of your work during an install. There's nothing like that feedback loop to help you grow. We love collaborating with other prefab companies. Like I said, we're doing a little bit of work with Simple Life Homes, and we've done some work with BC Passive House as well. And we will have a partnering company down in the Lower Mainland building panels for us as well, Porchlight Homes. So we really enjoy working with other companies and always learn a lot. And there's just so much to learn, and we're all on a similar quest just to make high performance buildings more attainable and just to increase the efficiency of how we do things. And that's that. Thank you.
Great, thanks so much, Jan. And our last speaker tonight is Leith Moore, who co-founded Our House in 2018 to provide affordable and sustainable housing solutions for urban families. He is in Toronto. This year, the firm delivered on its first prefabricated laneway house, known as an ADU here in the States, and completed turnover of its first 4 prefabricated 6-story Avenue townhomes. Our house is in the process of finalizing planning permissions for the start of construction of 8 new CLT Avenue townhome projects, together with additional laneway suite builds. So welcome, Leith.
Well, thank you very much. I'll share my screen. Everybody good? My beautiful little Main Street building.
Looking good.
Well, good evening. It's late here on the center of the country. So Our House, I'm a reformed developer. So I spent 35 years building condos, production housing, townhouses, everything you'd think of, for some pretty big companies here in Toronto. I am now devoted to, if there is a heaven, getting in. So I've co-founded a prefabricated off-site construction company that aims to basically help people self-solve housing solutions. So I no longer buy land and chop it up to build higher and more. I am now pursuing a smaller is beautiful approach. And because all those years I was a developer, I found building small was the most challenging and difficult task. And I've had a few ideas kicking around for years, and people said it would never work. For a while it didn't, but I guess it's fair to say I'm out trying to prove that it does. Really tackling the problem of lack of innovation in the construction industry. Tight avenues, Main Street, backyards, laneways. Our house is trying to combine the whole idea of building with wood, and I only build with wood, with offsite construction, to try and bring us solutions in the on the main streets that we haven't been able to do. And in Toronto, it's a massive market. We're looking at Toronto is, home to, I think, some years the most high-rise cranes in North America. I lost track of where we are now because I've given up the crane business and gone to small. But what we're doing is enabling construction in a missing middle. So our products are designed to fit into areas that traditional developers and builders don't address. We have solutions that work. Our avenue towns are anything from 5 to 8 stories. I'm actually working with the city of Toronto on a repeatable templated nonprofit housing mass timber program that is 10 to 12 stories. We build in the 4-story walk-up apartment range, and we're getting very active, in working through laneways and garden suites. It's a prettier word than ADU. How do we make all that work? Hired a guy out of Toyota to, if we're working in small, tight spaces, just-in-time delivery principles are everything for us. So bringing things from a plant to a site, having it prefabricated off-site, tilted up on-site, and making all that work involves all these parts. So I've had to learn Kaizen and talk to engineers who know logistics. It's a new experience for me. Just when I thought I knew it all, like I had fluvial geomorphology as a minor, as a developer, now I'm a technology expert in fabrication and logistics. We really are trying to combine a bunch of ideas to make this smaller, this beautiful thing work. And while I'm chatting, I'll show you our project. When I said we build small sites, I wasn't kidding. This is a 40-foot site in downtown Toronto on a major LRT line. And we built the entire thing from the backyard on a lot that's 110 feet deep. And we had 40 feet at the back, and that's where we built from. So we never had to close a lane. If you're familiar with city building sites, you're always closing streets and delivering on the street and trying to build these small sites. So therefore you don't. We've kind of developed a series of core principles that allow us to build from laneways. And that allows us to build from laneways, whether we're building 1 story or 2 stories as garden and laneway suites, or in this case, a 6-story building going up to 10 or 12. So the key principles are, 1, we start with the principle that we build with wood. Wood is good. Ontario wood is better. You can quote me, if only because I like to ship fewer distances. So we source Ontario woods and work with sort of local manufacturers. I don't own a plant. I don't own a robot. I manufacture relationships. We have a repeatable design. And the key for us in cost control in urban locations is that repeatable design. So everything behind the front wall of the building, including this back wall, is patterned and repeatable. Structure's done, architecture's done, M&E is done. We have a front window and a back window, so we get a lot of passive heating and cooling. We use radiant heating and cooling, tight building envelopes, ERVs, the whole suite of tools, green roofs, lots of water infiltration. So core design principles for us are very environmentally and sustainability driven. We build mostly rental products, so OpEx is as important as CapEx. Keeping those long-term operating costs down by building a better quality building is important. So we are a decarbonization, not only with the wood, but there's no gas. It's all electric and or geothermal sourcing. We work with municipalities, so the pattern building is not only with our BIM design, and everything we do is in 3D BIM, of course, but so we can do the design for manufacturing assembly, but it's also in our entitlements. So the City of Toronto is familiar with what we're doing. We get concurrent processes rather than sequential as a result of the fact it's a pattern build. And it allows the planners to go spend time on more complex projects. Mine are simple. It's a 20-foot or a 40-foot or a 60-foot incremental builds. Same plan, same approach to layout and parking. So they don't have to think about it. I make the submission, we get our approvals. Instead of it being a 2-year process, we're more like a 6-month process. Even my building permits are repeat. And the City of Toronto has a dedicated group for mass timber. I build mostly with mass timber. So my projects go through the same building review guys, and it's kind of a stamp again. It's a repeat permit. To go with that, so we're working with them. I'm a canoeist, so it's kind of like paddling downstream rather than, trying to paddle like a madman upstream. Nice when you get older. You learn to just let's go downstream and we'll raft the canoe and have a beer on the way down. Yeah. So going with that approval then is the design repeatability. The last part then is construction repeatability. We work in an IPD format, integrated program delivery, meaning I may be building individually small projects, but to my trades who are on all of my sites as a integrated unit. This is a 200,000 square foot building. I'm ordering materials on a larger basis because I'm repeating them. And I have a lot of contracts. And so these are trades who don't have to say, well, I'm just building a 15,000 square foot infill. No, it's like I said, it's a 200,000 square footer. We have pre-designed solutions for everything from 1 to 10 stories. And then that means that our contractors can deal with what we all know is a real problem in the industry. It's called contingency costs. So 50% of all labor costs on every contract, if it's a labor component, 50% of that labor component is walking around time. It's what if the plumber doesn't finish on time? What if there's a clash where you've got to put a mechanical something through a structural element, being on a hoist, just downtime. And so by working together and in a 3D and then building it and then building it again and building it again, over time, our labor costs start to come down. And that helps us offset, some of those swings in commodity pricing. It allows our contractors to do more, be more productive. And so that's one of our keys to addressing productivity, not just in-plant construction, less waste, faster, better quality control. But then when you get on site, folks who know what they're building because we've done it a few times. As I said, we have a range of products. It's interesting, about half of our current projects are for nonprofit builders who like the fact that they can get a fixed price, an adaptable design, and a fixed timing. Our construction time frame for a 6-story building on a main street, 0 lot line, building wall to wall, beside, carving out a couple of buildings and dropping in a new one. We're 6 months. Our backyard units are about 8 to 9 weeks complete. We use Passive House windows, Passive House slabs. They don't always end up at Passive House ratings, especially on the ADUs, because they're a little small to sort of physically generate those results. But both the lane suites and the 6-story builds are very much in demand with nonprofit groups as ways to, we're really building on land they own. And so the cheapest housing they can build is to rebuild what they have and turn a 2-story main street into a 6 or 8-story new build. This is the pilot that was finished earlier late last year. It's now fully tenanted. I own the pilot, built it, sold it. It's all rented up. And the building next door I built for the neighbors and said, hey, while you're there, we'll have it. Very Euro kind of design. You'll see in the bottom right there, that elevator opens directly into the unit. Every unit has a front and back window and has an outdoor space. And I'll give you a little fly around. I'm kind of happy with it. That Icelandic Galvalume is on a sunny day, blinding. I like it, but some people said, hey, I might choose a different color next time. So as I said, we build with wood. You're all familiar with all the benefits of wood, from, we grow a house every minute, to carbon capture, to some of my clients, particularly, we build a lot of transitional housing. The wellness aspect of exposed wood and people living with wood, the health and wellness part is something that we talk a lot about. Thank you. I think that kind of covers most of what I wanted to tell you. What we're really doing is trying to make housing a product and take advantage of that fabrication, repetition, faster for approvals, faster to build, more predictable. We do have, everything's in BIM, and you can end up with a kit of parts and have lots of parametric design opportunities. But we focus on trying to keep, provide 4 or 5 key solutions that are, maybe need some interior adaptation for intergenerational needs or barrier free, but I think that the key to build affordably in an urban setting like this is in trying to design a product that is suitable, slightly adjustable, but largely repeatable. And then I think at that point we've kind of done our bit. So that's what our house is all about.
Okay, great. Thanks so much, Leith. We really want to get to the Q&A because there's been lots of great questions, and feel free to continue to put your questions in the chat. But first we have a word from Zach.
Yes, indeed. So I want to just take a moment to thank the organizations who helped make things like this summit tonight possible. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stillcorp, and Zola Windows. Thank you also to our champion sponsors, Icon Windows and Doors, Proseco, and Desiga. And thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan, Brooklyn Solar Works, Euroline Windows, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood Teestead. Thank you to our sponsors.
Okay, great. And thank you so much again to all the speakers for their time and expertise. And now Ilka Cassidy from Holtzram Systems is going to be helping me out with the Q&A. So Ilka, who's our first question?
Well, I just wanted to say thanks for all the great presentations as well, and especially because they were so detailed. It's so awesome to just look behind the scenes a little bit and basically demystify prefabrication a little bit. And we do have a lot of questions. I'm going to call the name of the one who asked the question, and they can please unmute themselves and ask the question. And I apologize if I'm saying your name in a very thick German accent. Can't help it with names. So the first one is actually from L. Moskowitz. Is he or she still around? I guess not. So I can just ask the question. I think it was addressed to Amy, but I think it could be basically for everyone. And the question was, will you address finished cost for various design constraints? Amy, would you like to answer that?
Yeah, sorry, I was just trying to find myself here. So, yeah, great question, and always something that everybody wants to know, and it's really spec driven, right? So we can build to whatever level of specification, and I don't mean to be misleading at all, but we can build to a developer spec, we can build to a super high end spec. So the cost is really 100% dependent on what level of finish you're desiring for the project.
Okay, thank you for the answer. The next one is for you as well, and addresses the air tightness. I think you responded a little bit in your presentation already, but the question was from Robert Haw. Maybe he would like to have an answer a little bit more in detail. Robert, would you like to ask a question? I guess he's not around anymore either. So his question was, are your panels made to be airtight?
Yeah, so I mean, as I mentioned in the presentation, not all of our folks, so greater answer is yes. I mean, in terms of flashing and insulation, quality insulation installation, we do QII inspection on all of our panels. Whether or not the panels, when they're installed on site, are fully gasketed, that's really up to the individual architect and development team, how far they actually want to make that airtight. So if, again, we're building to specifications that the architect is providing to us. So if that's the requirement, then yes, we'll build to that. We don't have the capability for doing the testing in our factory right now, nor have we actually had the opportunity to build a passive house. We'd love to take on the first one.
Okay, great. The next question is also is about the installation, typical installation.
Oh, yes, sorry, there was a little interruption. I think you
Yeah.
asked about the installation, our standard.
Yeah, your typical installation approach.
Yeah, so right now for most of our projects, unless we're building in cold climates, so here in Southern California, we're using rock wool as our standard. Sometimes there is a requirement for rigid insulation on the exterior. We have the same kind of thermal break issues, but in reverse. You know, we want to keep the heat out rather than keeping the heat in for the colder climates. When the project requires it, we'll also do spray foam insulation. So again, it's really project specific what the installation requirements are, but our standard typically is the rock wool.
Okay, thank you. And then I know Martin Felker is still in the audience. Would you like to ask your question?
Yeah, I was curious whether a whole team travels with the construction material and puts it together, or whether it's just a foreman.
Yeah, well, I
also-
think that's a great question for everybody because we're all different in that respect. So for plant prefab, we do not provide that service. So we coordinate with the site general contractor and the transportation team as early on as possible. We like to get the whole team assembled as early as possible because we think that's critical to the overall success, not only for understanding the scope of work, who does what, us versus the site general contractor. And I mentioned that installation instruction that we put together. We review that with the general contractor ahead of time also, and we invite that general contractor to come to our factory so that they really understand what they're getting before it's delivered. And then I'll let Andrew talk about what Unity Homes does.
Yeah, we pre-pandemic, we would typically send 2 people from our shop to lead the raising crew, and we would hire 2 local carpenters, ideally from the general contractor who was going to finish the house. And that hybrid crew would assemble the panels. So we had the expertise and the tools and things from our crew, but we weren't taking too many people out of the shop to assemble the houses. But by sending people from the shop, there is that direct feedback loop between the site and the shop that's so important that that others have referenced. But with the pandemic, we shifted to all in-house crews basically, which is a bit more expensive for our clients. But we also found, we were sort of reminded that that's what we used to do in the old days, is just send out 4 guys and bang the thing out. And when you have 4 people who really know what they're doing, things just happen more efficiently and better. And so we've been doing that and enjoying that, but that's also caused more disruptions in the shop flow. So it's a balance, but typically we're taking responsibility for the assembly of the panels to the stage of it being a weather-tight shell on site.
Okay, thank you. Does any of the other presenters would like to answer that question? Because I feel like it's very interesting, very important.
I think along the same lines as both Amy and Andrew. We do most of our own installations with a full team of our own guys. He did mention about for further jobs that are further away that we'll often incorporate a couple carpenters from the general contractor team to work with our own. And COVID was its own thing. Jan mentioned that we worked with Cart Collective before. We had a job down in the US where his US team was able to help out with us because we couldn't really get people over the border. So it's usually a bit of a different thing, but I think for us, because it's such a high level of custom homes we're typically doing, that we need to at least have 1 or 2 of our own people there to manage the install, because they know inherently with the drawings and with our system how the building's going to go together.
I can say that we're scaling from doing $10 million of work last year to $100 million this year, which is not easy. And the biggest challenge we have is tilt-up crews. And there are very few of them experienced handling mass timber, and even fewer experienced handling mass timber in a city, like getting in and out of a downtown tight location. And so some of our, one of our local carpentry unions has a mass timber school basically to try and train up carpenters. But there's a need to train people dealing with mass timber. It's more like iron worker. It's more like installing big pieces and swinging around an old chunk of iron that you can imagine they used to do. And so that's there's been a doubling of CLT supply in Canada in the past year in terms of new plants opening up. And demand's gone up, not quite even half. But so we have a lot of CLT capability around, but not nearly enough people to stick them up.
Yeah. How about you, Jan? You said you like to travel.
Yeah, we have the problem that everybody wants to go. So it's a nice problem to have. I think people can get a little bit tired of the humdrum of the shop life and need a little bit of outdoor experience, a little bit of sunshine. And it's a nice thing for us for the feedback loop, like Andrew said, and that's really amazing to have that, because there's nothing like being on a ladder in the wind and realizing you could have taken an extra minute to tape something better or at all, or whatever it is. But yeah, we have to keep the shop running too. So we've got a pretty small shop. So if we lose 3/4 of our crew, it's one person or two people on their own. So we have to balance things. And as well, I love going on installs, but if I'm away on an install, I can't be at the supercomputer. And if you're not at the supercomputer, you're not able to plan, put in a bit more time planning. So, but yeah, we do have the US install crew, and they are, they'll go anywhere. They love it. It's it's good. Hope that answers your question.
So you haven't partnered at all with local teams?
Oh yeah, sorry. No, not yet. We are always on the lookout for people, and we do meet people because this is a tight-knit community, as you all know, and we have people reaching out to us via the Instagram and such things, and people might know where we are and reach out, and yeah, we're trying to increase the ringers. The number of ringers we have out there is always increasing, but we also have some initiative to train local contractors. And we haven't done a ton of it because in the past we've reached out and we've established some parameters, like, yes, you want to reduce your install cost and obviously pay less live out allowances and accommodation charges and travel and all that. But historically, those people don't really, it's not that they don't show up, but they are never quite as invested as you might think at the outset of the negotiating. And it's sometimes just a really good idea, but when it actually comes to an install time, there are other tasks that these people could be put on. There might be a foundation elsewhere for them to build. So we're definitely interested in it, and we're setting it up for one of our installs very soon with the public. And I'm optimistic that it'll go well, but historically, they're less interested on the day versus what was discussed a month before. So we'll see what happens.
Okay, great. Thank you. So the next question is from Shannon. Shannon, are you there?
I am. Hi, Ilka. Thank you.
Hi.
And what a great presentation. Great speakers. Amazing topic. Really nice to see everyone pushing prefab forward. I don't remember which question you're referring to because I think I asked 3. So I'll just pick one since there are so many folks.
Yeah.
I would love to hear how people are aiming toward carbon with their designs and with their data attachments. It's nice you're all using the same software. Maybe it can be something that can be shared and scheduled. And someone else even asked about recyclability. Are those things that some of the speakers are considering adding to their data attachment?
Anyone?
I guess I'm not really clear what you're talking about, data attachment and carbon. Could you be a little bit more specific what exactly
sure.
you're asking?
Yeah, sorry, Amy. Thinking like environmental product declaration sheets or toxicity. So I know we're all trying to use carbon smart materials where we can, but since we can attach data to the digital twin and that wonderful model that everyone's making to prefab, is there a possibility for attaching information about the materials with regard to carbon and toxicity?
I mean, I'll take a stab at that. There certainly is that potential with the software, obviously, to do that kind of attaching. And that's one of the reasons that we've taken on for the last few years the development of our own software. We're working with CAD Work for the design side of the software, but it's somewhat limited. You know, it was originally developed as a timber design and engineering software that would speak to the CNC machines. And over the years, it's become better at doing design, but it is limited. And so I know that there are add-ons for Revit and other software applications that are working with that building information, but we're finding that with what we want to do, it includes not only the sort of sustainability information, but also the energy modeling. Right now, everything's pretty siloed or compartmentalized, and it can be challenging sometimes to bring the different software applications to bear on a single project to get them to do what they all do best. And so we're working on developing software that would make it easy to attach that kind of sustainability information to the different elements within the 3D model. Already we're providing a certain amount of information about what those materials are and how they go together that's embedded in the model. And I think it's easy to imagine embedding a lot more that then facilitates decision making and about mechanical systems and other things from that 3D model. Not sure if that gets to what you're asking, but that's sort of the direction that we're headed.
It definitely is, Andrew. Thank you so much. Do you plan to use the model after project closeout and in essence, give it to the client as a tool at all?
That's part of the idea, yeah, because we actually, you asked about recyclability, or somebody did, and ideally the buildings that we're building are going to last for 100 years or 200 years. So we're not really building them for disassembly, I guess. We want them to last a long time. And so with all that information that's developed during the planning and construction, you have a wonderful foundation for basically a digital owner's manual. We are providing owner's manuals to the houses that we build, but we could be doing a lot more to contain that information. And so it includes everything you need for maintenance, or if you eventually do want to build an addition, all the information is right there for the owner or future builders.
Bravo, Andrew. Thank you.
I was gonna start. I'm glad you spoke first, Andrew, because I was gonna say, sure, no problem. But I'm glad that you spoke before me. But I think CAD Work might be really good. Correct me if I'm wrong, but I think it might be really good at taking information that's already been figured out and then applying those attributes to parts. And it might be really good software for summarizing, but maybe not so much for creating the original data.
Yeah, and I'll just jump in that as a company, we have a carbon neutral pledge, to be carbon neutral by 2028. But additionally, we have our B Corp certification. And as part of that certification, every single year, we have to quantify how we are reaching all of our goals. In particular, this, zero energy, zero water. We've got a pretty big commitment to do this. So I think Andrew's kind of tapped into that capability of what CAD Work does have in terms of the data that's already there. And we're constantly looking into ways that we can make ourselves more accountable to not only the materials that we're using, but the way in which we're manufacturing that, and then the way in which we're actually running our factories.
Thank you, Amy. I think the next question is directed to you as well. I don't see the person who asked the question in the participants list anymore. Jordan Parnas, are you still around? I don't think so. So I'm going to just ask his question, which is, what are the geographic constraints? Can they be trucked anyway? So referring to your modules and panels.
Yeah, I mean, I think I probably got all the questions since I went first, but I think all of these questions are really applicable to everybody. So I'll just say that, one of the reasons we're starting this new facility that we're calling the hub is that we're going to create panels there that then we can ship to our other facilities. But there is a certain tipping point in terms of distance, right? Because you need to think about the cost of shipping. So shipping panels is a lot less expensive. So sometimes, like in that project I shared, that we're shipping from Southern California to Winter Park, Colorado, the reason that we didn't ship 2 large modules, instead we did the panels in small mods, was we saved them $250,000 for just transportation costs. And that's a distance of 1,200 miles. We found for large volumetric modules, the sweet spot is really like around 500 to 700 miles. And then for panels, again, it's really a balance. So it's a question of thinking, why do you want to do prefab in the first place? Is it a time savings? Is it a cost savings? Then you need to weigh those transportation costs over your overall build time and your overall project costs. So it's not really a simple answer, but again, large volumetric mods, our radius is about 500 to 700. And then, like I said, we're shipping 1,200 miles for panels to Colorado.
For me, I find that shipping, like logistics, is a huge part of what we have to plan for. And the reason I do flat pack panels and not volumetric. So I was, there's a 3D volumetric, which, obviously, and I'm the 2D, which I feel kind of like I'm a cartoon. I'm just a little 2-dimensional thing. But 2D panels, if you think about where I'm building, I'm moving from a bigger space, more wider roads, lots of lanes, to a very small space that's tightly constrained. So I can't deal with volumetric at any point. There's too many hydro lines, there's too many streetcar lines, there's too many people, there's small lots, small access points. So I have to basically deal with getting my panels built. That's why I don't really want to own the plant, because I need different panels for different solutions. I need CLT panels in some cases, dimensional panels in another. So my real focus is a last mile assembly. I need to bring things together and then ship a fully clad panel from the outside to the in to a site to be able to do 0 lot line development. I don't have the luxury of being able to put it up and then come and stand around and put on the exterior. It must be done in advance. So size, weight, and looking at each site to see what you can get in is the key. And I think that therefore for the last mile assembly is really constraining versus the ability to ship hundreds of miles.
Thank you. So the next question is from Kobe Vardy. Are you still around?
Yeah, I'm here. Howdy.
Would you like to ask a question?
Oh yeah. I guess I was interested to know, and this is for all the presenters, like, what's the main value proposition when you are kind of discussing with clients using your kind of means and methods relative to traditional construction? Are you mainly talking to cost, or are you mainly talking to schedule, or like what is the main driver that kind of pushes people in the in your direction, basically?
Maybe I'll start it off. I think there are a bunch. Thanks for the question. I would say availability or lack thereof of local labor is probably the one we hear the most of lately. Followed up by predictability, leveraging the design time software, things like that. But yeah, labor is the number one.
Yeah, I'll second that, and then I'll add, I guess, speed of construction, mainly because prefabrication can be done. We sequence it properly during the concrete stage of construction, such that when the concrete is done on site, then we're just dropping an envelope on top. So we're kind of skipping that stage of construction, which would be traditional framing. So there are, especially in commercial jobs where there's incurring costs for contract management and all that kind of thing. I think that's a big one.
Yeah, and I'll just jump in and say that, in some of the regions we're building, labor costs really do drive it. So particularly in the Tahoe area, we might be seeing triple the labor rates than what we're paying. And we're paying, prevailing wages and good rates for the folks that work in our factory. But if we're comparing Southern California, Inland Empire labor rates to Tahoe ski areas, there's a huge disparity. And then the overall time savings does contribute to that as a cost savings. So as Kyle mentioned, we're able to build simultaneously with the foundation, and we're also able to build multiple stories simultaneously. So your overall build time is significantly decreased, which ultimately then can potentially have a cost savings to your customer as well.
Thank you. So up next is Paul. Paul, I can see you.
Yes, thanks, Elke. My basic question is how long is the design and coordination process compared to the build time? And the reason I say this, I have the pleasure of working with Elke and Steve on a project as not the architect exactly, but our function is as the architect on particularly on a timber frame project with modular or with prefabricated panels. Luckily, we sort of, the way that the contract is set up and our role is that we didn't really get burned by fees. But what we found is that, Jan, you had a sort of a linear process of, pre-design, SD, DD, CD, ending up in construction administration. But that gets all jumbled up, or at least that's, I think that's probably true for everything, particularly because there's a lot of construction administration stuff that happens in DD or before. And I'm sure on the contractor end, or particularly the general contractor end, they're finding that they're having to get their subs on board much earlier because there's lots of decisions that have to happen in the schematic and DD phase. It certainly affects the contractor, but as the architect, it really affects us too. If we don't have a sophisticated client that understands that when I'm looking at a 3D model of the timber frame or the panels, that I'm actually doing construction administration work, that could be, have some conflict from the fees. Luckily the design fees are a fraction of what the building fees are, but it's it's a real issue that I'm sure could come up depending on if you don't know how the building is going to be constructed. Is it prefabricated some level or is it all stick built? So I guess the question is, because Amy, you mentioned that you thought the whole process was faster than maybe the regular design bid build process. Does everyone think that that's true? That overall, from beginning to end, it's faster, or is it? Maybe that's the question, I guess.
Yeah, I can understand it because it's a lot, right? So as the architect, it seems a lot of us are working in CAD work. So I'll talk about how we work. So typically, if you're the architect designing a project that plant is going to build for you, you as the architect are still responsible for doing 100% CD package because we're a custom fabricator. So what we do then is we'll help you understand from the very beginning, what's the best prefab concept for your project, right? Is it all volumetric modules? Is it mods and panels? Maybe you've got really big constraints on your site and we can only do panels. So from the very beginning, we're gonna set that tone. So then the project will be engineered with that intention. So we're working with you to refine the design to make sure that we have the chases that we need for MEP. We're thinking about the writing of everything as you're designing it. So then when we get that final CD package from you, we're putting it into CAD Work and then we're developing our shop drawings. So time to engineer and design is the same as if you're building on site. Potentially there's a little bit more time up front because we're now drawing a complete set of installation instructions and shop drawings. But then once we start building, that's where the time savings comes in because we've already built it in CAD. So we know where the joist hangers are going. We know where the vents are going. We know where everything is going to be. We're not having to send you RFIs during construction because we've already sent you a whole bunch of RFIs during that CAD work process. So the time savings really starts at the level of fabrication. That's where you're going to see the most significant time savings. And then again, depending on the size of your project, you know, multifamily, single family, we're building in parallel with your site, then that's your overall project schedule can get greatly, in some instances, really diminished. Does that answer your question?
Sure. I guess the answer is it depends. But
Well,
yeah,
I mean,
yeah.
it just like, you know, if you're building, you know, every single project you design is going to be different on site as well. But I mean, in terms of, I think a lot of architects assume that if you're going prefab, that you have less drawing to do.
Right.
And then with some companies, that may be the case if you're using prescribed methodologies, you know, where they have like, and I can't remember, sorry, but I think one of the speakers talked about they have 3 wall panel types, right? So now you're automatically using their standards for your design. For us, we have some standards, but mostly we're custom. So that's why you really have to still complete a full CD packet.
Right.
Yeah, I think it's really tricky. You know, I think you guys, architects and designers, are in a really tricky spot because there is a ton of variation, you know, ton of different options. And you, in order to get the most out of a relationship with a manufacturer, you kind of need to commit to them pretty early before you really have accurate pricing, perhaps, you know, or even before you have the concept developed to a point at which you could get accurate pricing. So I don't really know if I have an answer for you either, but I sort of feel like, I guess I'm just empathizing with you. I think it's a difficult thing to be put in a position where in order to maximize your effectiveness, you kind of have to take a leap of faith. And yeah, that's tricky. You know, I think we're at a point in this industry in North America where there is no standard building panel. You know, there is no standard way to do it. And we're trying to sort of say, yeah, we have three wall systems, but you know, each one of those wall systems has 10 variations. You know, it's not like it's not really plug and play. It's pretty custom still. That's just, you know, intended to be a starting point, right, or a guideline. But yeah, I don't know. It's definitely not a linear relationship. You know, I think we poke ourselves into that line of activities whenever we can, and the earlier we get ourselves involved, the better. But yeah, it's a chicken and an egg kind of chasing each other and tumbling down the road, I think.
Yeah, you know, it's like interesting because I spent, like I said, 35 years doing one-offs, you know, and I'm to the point where I hate architects. It's like, you know, you charge too much and it takes too long. So it's, you know, it's half a jest, but it's half true. So what I have is shelved BIM products and architectural designs that I can clad, you know, dress up in different ways. But I am now always faster to get from my concept. What do you want it to look like? And I can get into a building permit much more quickly. It comes with a cost. It's not that my products aren't beautiful. To me, they are. We love all our children differently, but I am not a custom in any way. And I'm the anti-Cartera. And is it too early to use the K word still? We haven't talked about it in the fabrication world.
I think we're okay now.
We're okay now. I actually have a couple of them working for me on contract, and we tell Cartera jokes sometimes. But you know, you can try and boil the ocean at your peril. So you have to pick your size, and if you're depending on the size you're aiming at, you can do more custom. If you're trying to do what I'm doing is scale quite large, custom is a problem. And so it's a very different set of parameters. I feel like, you know, I'm sitting at one end of the equation from the other panelists who do great work. They're just at a different, aiming at different locations to build in a different style and much more custom. Probably much more passive house too, for now, but I'll catch up.
Thank you.
Well,
So
Sorry, I just have to jump in here because we only have 3 minutes left. I think we have time to squeeze in one more quick question before we have to say goodbye to everybody. It's been such a great event. But I think we have one more question. Maybe Robert Tanner, did you want to ask your question, or do you think it's been answered already?
I'll ask a little bit about lead time, and thank you. I'm about, we're getting ready to build, and Ilka is helping us out on a passive modular build in Santa Barbara, California. And just wanted to ask Amy a little bit about, from the time you've got the local building department approval and the third party module plan checker approval, what is the lead time that you're seeing with plant to get from after approval through your factory, assuming it fits and the build works within your system?
You know, and I don't mean to be vague at all, but obviously it depends on the size of the project, right? And availability of materials. So if we take purchasing materials out of the equation, we've seen 30-week lead times for a lot of our window manufacturers right now, right? So if we talk about just building, how big is the project?
4,500 square feet.
So, and it's 100% custom design,
Yes,
high level of finish.
exactly. Yes.
So, you know, without obviously I'm answering this without seeing any drawings, without seeing any design. I would say 6 months, you know.
That's optimistic.
So, I mean, again, obviously I haven't seen anything, and that's assuming we have all of the materials in the factory, right? We're, you know, so, and then that's partly why we're doing that CAD work drawing ahead of time, because we're using that to purchase our materials. That creates our P-bombs for us, right? So everything is executed from that CAD work file.
Right. Great. Thank you. Thanks for that info.
You're welcome.
Thank you so much, everybody. We've had such great questions, and I wish we had more time, but there will be other sessions. So I really want to thank everybody for attending. And I think, Zach, maybe you had a couple words you wanted to say there.
Oh, I mean, it was just so fun tonight, and what an amazing group of people who came together to be part of tonight's event. And thank you so much to the presenters for making it happen. We're really appreciative. So thanks for being here.